All right, Geometry Geniuses, we have a big scary proof here, but it's okay. You guys got this. All right, so let's take a look at what we have going on in this problem. Here we have a segment PQ. Do you see PQ there? Let me get my highlighter and let's just highlight PQ. All right, and then they tell us that point A is on the perpendicular bisector of PQ. So we know that, whoops, let me change my colors here. We know that this line that point A is on is a perpendicular bisector. And because it's a perpendicular bisector, we know that it's a 90-degree angle here and that these two sides are congruent because the definition of bisector tells us that it splits that line in half. The definition of perpendicular tells us that we have a 90-degree angle here. What they're trying to prove is that A and P and A and Q are the same length. Okay, so they're trying to prove, let me get another color highlighter, I'm going to do this one in pink. They are trying to prove that this guy and this guy are congruent. Now, one easy way that I think they can do that is by showing that these are congruent triangles. So I think that's what they're going to do here. Step one, remember in a proof, we've got two columns. We've got the statements and then we've got the reasons. Okay, so the statement is, they say point A is on the perpendicular bisector of PQ. They gave us that information, so that's there. All right, now they say that PX is congruent to QX. That's my two yellow ones up here. PX is congruent to XQ. How do we know that? Well, we said that's the definition of a bisector. Definition of bisector. Bisector means it cuts it into two equal parts. So those two bad boys are congruent. All right, angle AXP, that's this guy here, and angle AXQ are right angles. We knew that, right? And we knew that because we know the definition of perpendicular. Okay, perpendicular means that we have formed two 90-degree angles. So we're just going to write that right here, definition of perpendicular. Perpendicular lines form 90-degree angles. All right, here, why do we care that all right angles are congruent? Because we're going to say that angle AXP is congruent to angle AXQ. Okay, that's just in the step before they gave us those two. And we're just saying that these are both 90-degree angles, so they're both congruent. All right, then they say segment AX is congruent to segment AX. That's my kind of teal color up here. And that's just the reflexive property. Remember, that's like looking in the mirror and saying, hi, me. Okay. So then they say triangle AXP is congruent, sorry, sorry about that, to triangle AXQ. So the triangle on the left is congruent to the triangle on the right. Well, what we know is that we've got a side angle side congruency postulate here because this side and this side are congruent. We know that these angles are congruent, and now we know that this side is congruent to itself. So we've got side, angle, side congruency. So side, angle, side postulate tells us that these two are congruent. And then the last one says AP is congruent to AQ. How do we know that? And that is this long one right here. Corresponding parts of congruent triangles are congruent. And usually you'll see that abbreviated as corresponding parts of congruent triangles are congruent. Okay? So that's what goes right here. Therefore, they can say that point A is the same distance from the endpoints P and Q because we know that this pink side and this pink side are congruent because corresponding parts of congruent triangles are congruent. Hope that helps.